Okay, so this is the exam review solutions for the Unit 2 on exponents. As before, I'm going to begin with the non-calculator portion of the paper. And so at the beginning, you can see our instruction is to simplify each of the following. Make sure we do not leave any negative exponents in the final answers. So first question over here, it is a multiplication question. The rule is to write down the base or bases in this case, add the exponents. And so my three bases in this case are x, y, and z. Any base without a power, of course, is assumed or known to be a power of 1. And so in this case, we're going to go through and add the powers of the same bases. So I'm adding 1 and 2 to give me 3 for the x cubed, 3 for the y term, and for the z term, we have 1 and 1 to give us z squared. Okay, exactly the same procedure on the second question. And so I have x to the power of 1 and 1 is 2, y to the power of 3 and 5 is going to give me 8. So moving into question number 3, we have a small extension here. The two parentheses written next to each other are once again multiplication, so that's no different from the first two questions. What we're really dealing with here, or what is a little different, is the term that has got x to the power of 0. Hopefully you recall that any term to the power of 0 is in fact the number 1, and so we can essentially ignore those. So the rule remains, write down the base, add the powers, and then we also have a 5 multiplied by 3, so that's going to give us 15. X to the 0 times x to the 0 is x to the power of 0 plus 0, which is x to the power of 0, which there's no need to write. And so we can leave that out, or if you did in your answer put x to the 0, that would be fine. And then we have y to the power of 4 plus 5, which is y to the power of 9. Okay, slightly different question in this case because now we have parentheses raised to a power. When we have parentheses raised to a power, the rule is we need to write down the base or bases in this case. So we have 3 bases in this case. The x, the y, and the 2 is also a base. And we are going to multiply the exponents of each of the bases. So I'm going to do that as the first step. So it's going to become x to the power of 2 multiplied by 4 is 8. 2 to the power of 1 multiplied by 4 is where the 4 comes from. Y to the power of 3 multiplied by 4 is 12. In this instance, if you wish, you can rewrite 2 to the power of 4. That is in fact 2 times 2 times 2 times 2, which is 16, or you may leave it as it is. The last thing we would need to do in this case is to check whether any of the bases were the same and whether we could simplify further. In this case, we have 3 different bases, and so there is no work we can do beyond this. Okay, and the fifth question, nothing outside the parentheses, so really the parentheses aren't relevant. We have a series of bases inside. We have a combination of negative exponents as well. So we have 2 choices in this case. The first choice would be to eliminate any negative exponents by moving the term. So you may recall a negative exponent implies a fraction, and ultimately what that means is to get rid of a negative, if I move that 2 to the minus 1 from the bottom to the top, it would become 2 to the positive 1. And we could do that as a first step. Alternatively, and this is in fact what I'm going to do, alternatively what we can do is simplify the bases first and then deal with the negatives. Either one will get you to the correct answer. So what I'm going to do is I'm going to write down each of my bases, so 2, x, y, and z, and then since this is a division problem, the rule is subtract the exponents, and so I'm going to say 5 minus 1, 2 minus, in this case, 2, 3 minus 2, and for the z we have 1 minus 2. And so I'm going to simplify each of those. 2 to the power of 6, x to the power of 0, y to the power of 5, z to the power of minus 1. And our final step is to eliminate the negative exponent. And the way we're going to do that is to move the z to the minus 1 into the denominator, and then the exponent becomes a positive. x to the 0, no need to write that because, of course, the numerical value of x to the power of 0 is 1. Okay, go ahead to the second page. So now we have some graphs. What we've been asked to do is give the domain and range. Remember, the domain is the set of all x values which apply to this graph. This is an exponential function in the form a times b, which is the base to the power of x. Those are going to continue forever in both directions. The domain of exponential functions is x is an element of real, or another way you could just write that is x is all numbers. For the range, which is the set of y values, in this case, hopefully you realize and recall that as the value of x increases, the value of this term decreases because it's a fraction. It's going to get smaller and smaller and smaller, and multiplying by 3 is not going to have a big effect on that. And so the range in this case is y greater than 0, or another way to say that, all positive numbers. Okay, and that's our domain and range for an exponential function. In this case, this would be an exponential decay function because as the value of x increases, the value of y decreases. So very similar here. This is an exponential growth function because as the value of x increases, the value of y increases, as you can see from the shape of the graph. And so the only difference here is this plus 1, as you can see, has caused the entire graph to shift up. And so domain in this case, x is all real numbers. The range in this case, y greater than 1. Okay. So more simplification of exponents. These are going to be more complex. They now involve a combination of rules. And so the additional thing we need to watch out for in these examples is the idea of PEDMAS, order of operations. Becomes very important here because we have questions with exponents, and then once we've sorted those out, we do have a multiplication, and so we do need to ensure we deal with the exponents before division or multiplication. Okay, so that's what I'm going to do first. And so for each of these parentheses, I'm going to write down my bases, and once again I have 3 bases in the first parenthesis. I also have 3 bases in the second parenthesis. And for each of those, I'm going to write down the base, multiply the exponents. Technically as well, if you look at 1/3, you can count that as, in fact, 2 separate bases. One is also a base, the difference being one is unchanged by multiplying its exponent. So I'll show it to you, although it won't make any difference. I have 1 to the power of 2 times 1 is 1 squared. 3 to the power of 2 times 1 is 3 squared. X to the power of 3 times 2 is 6, y to the power of 2 times 2 is 4. That's our first term simplified, and what we've done is gotten rid of the exponent outside. The second one is going to be 3 to the power of 1 times 3 is 3, x to the power of 2 times 3 is going to give me 6, y to the power of 1 times 3 is going to give me 3. Okay. As I said before, this term over here, 1 squared, is just 1, and so that really doesn't make any difference squaring the 1. Now I continue with the second phase, which is to write down the bases and to add or subtract the exponents. So what we have over here, of course, is 3 cubed over 3 squared is effectively division. And so let me write down my 3 bases. It is 3, it is x, and it is y. And then in order to get our answers, we have 6, x to the power of 6 multiplied by x to the power of 6. We add those and we're going to get x to the 12, y to the 4 times y to the 3. We add those and we get 7. And for the 3, we have 3 to the power of 3 divided by 3 squared. We're going to subtract those 3 minus 2. So the power of the term on top, the numerator, subtract the power of the term on the bottom, the denominator, and so that leaves me with 3 to the power of 1, and that's the final answer for this question. Okay, same kind of thing. What we got to do here is watch out for PEDMAS, order of operations. The first set of parentheses over here does not have an exponent outside, so that's going to remain unchanged. But again, consistent with the order of operation rules, we want to make sure that we are not multiplying these terms before dealing with the exponent. Otherwise, we break the rules of order of operation and we'll end up with the wrong answer. So I'm going to begin by leaving the first parenthesis exactly the same because I need to deal with the exponent first. The way I'm going to deal with that is when we have a set of parentheses raised to a power, the rule is we write down the bases and multiply each of the exponents. And so I'm going to write down my bases, and in each instance I'm going to multiply. So minus 2 multiplied by minus 1 is going to give me plus 2, minus 2 times minus 1 is going to give me plus 2, minus 2 times 3 is going to give me negative 6. And so I've now dealt with the parentheses. I'm now left with a multiplication problem. As I mentioned before, we do have a negative exponent. We could deal with that straight away, or we could deal with that as the last step. Either one will get you to the same place. In this case, I'm going to deal with it as my final step. So I'm going to multiply, write down each of my bases, and I'm going to add the exponents. So I have 4 to the 1 plus 2 is going to give me 4 to the 3, x to the 2 plus 2 is going to give me x to the 4, y to the 2 plus minus 6, so it becomes 2 minus 6 minus 4. And the final step, of course, since we're not allowed to leave negatives, no negative exponents in the answer, would be to move that y down. And so let me just move over here. Final answer, 4 cubed x to the 4, and the y moves from the numerator to the denominator and becomes a positive exponent. Okay, next page. We're now moving on to the portion which allows for the use of the calculator. It's not going to be required all the time, but is allowed. And so what I'll do is I'm going to bring my calculator in at this point for some of the problems. Some of them you're going to find it is not necessary, and in fact the use of the inspire in this case doesn't add a great deal of value because we don't focus too much on the graphs in this unit, although we could definitely use the calculator in order to sketch a graph, but there are no questions on that in this particular review set. Okay, so what I'm going to do is just go ahead and start with these, and then I'll need to stop this video and record the second part of this in a second part of the video. Okay, so scientific notation. You've been asked to simplify if necessary. So in number 9 there's no simplification, in number 10 there is, and we're going to write your answers in scientific notation. So do recall the rule for scientific notation is that the first number should be between 1 and 10, and then it's multiplied by 10 to the power of whatever we need in order to have the same number. So the purpose of scientific notation, of course, is to work with large numbers and allow us to make estimates. Okay, so in this case what I'm doing is I have a decimal point over here. I'm going to move that 1, 2, 3, 4, 5, 6 places, and so I'm writing 5.611 multiplied by 10 to the power of the number of places I moved, 10 to the power of 6, and that is our scientific notation for the first part. For the second part, a little bit trickier. I'm going to use the calculator. For the first little bit, I need, let's go into my calculate, I need 11.23 multiplied by 4.8, and that's going to give me 53.904. So I have 53.904 multiplied by, and then what I'm going to do over here is when I do times 10 to the power of 2 times 10 to the power of 8, I'm going to write down 10 and add those exponents. And then the last piece here is to realize that this must be rewritten again. I have to move that decimal place, and so it becomes 5.3904 multiplied by 10 to the power of 11, because I need this first number to be between 1 and 10.